In the previous session, we concluded that when electrons flow through loads or resistors, there is dissipation of energy. The rate of dissipation of this energy is what we call power. When we say an electric kettle is rated at 50 watts, it means the rate at which it is dissipating energy is 50 joules per second. Likewise, a bulb rated 3 watts means it's dissipating energy at a rate of 3 joules per second. However, in electricity, sometimes the electrical power is expressed in terms of kilowatt hours. Think of the kilowatt hour as a unit that is used to quantify the amount of electricity. Let me use an illustration. Let's take a case in point. I have this cup right here. Inside it there is some sugar, right? I have a spoon right here. Now let's imagine that I am having a very big bag of sugar. This bag is filled with sugar, but I want to sell this sugar. I want to distribute it. Now I have two options. I can either use this cup to distribute this sugar, or I can use this spoon. If I am to get this spoon and use this spoon to distribute sugar that is in a sack, I'm really going to take a lot of time, right? But it is more convenient if I use this cup. Now, I can use this spoon, yes, and I can say that each sugar that I'm going to give out, each spoon of sugar costs 100 shillings. And so if somebody came with a very big polythene bag and they want, let's say, they want the polythene bag to be filled with sugar, it means if I'm selling each spoon at 100 shillings, I'll keep scooping from the big sack to be able to sell, to give to this person, but it will take me a lot of time because this spoon is too small. So definitely the convenient choice would be for me to use this cup, because with this cup I will be able to give out too much sugar within a very short time. So what does that mean? It means that instead of using this spoon, I'll use this cup as my unit. So I'll say every cup of sugar that I give out will cost me, I'll expect a payment of, let's say, like 1,000 shillings. So now this cup of sugar becomes my unit, or the standard upon which I'm going to use to sell sugar. So this same analogy is the same when it comes to electricity and billing of electricity. We know that electricity is when it's flowing, energy is dissipated, and the rate of this dissipation of energy is what we are calling the watt. So now, just like this illustration I've used, when the utility companies are billing electricity, they can bill it in terms of watts, and billing it in terms of watts could be equivalent to billing electricity using this spoon. But you see, we use so many watts of electricity every other day, and it would become tedious for the electricity company. We already determined that electricity flows in terms of watts, and 1 watt of electricity is 1 joule per second. So just imagine that that watt or that joule per second is like this spoon. And now I am giving out electricity to the people. If I give out electricity to the people while I am using the standard that I'm going to measure the electricity, or I'm going to bill electricity in terms of watt, 1 watt, it's going to become tedious. So what do? I say that I'm going to get this 1 watt of electricity and count 1,000 watts. So I'm going to group the electricity in terms of 1,000 watts, 1,000 watts, 1,000 watts. So when I have 1,000 watts collected, that is equivalent to this cup. So it means I will be selling electricity in terms of 1,000 watts. So it means I create a standard and say that 1,000 watts of electricity is equivalent to 1 unit of electricity. Let's first look through this here. We know that power is going to be equal to work done over time taken, and 1 watt, which is the SI unit for power, is 1 joule per second, which is that. However, when we are billing electricity, we are going to collect the watts into 1,000. So that's why the kilo comes in. Kilo means times 10 to the power 3. So 1 kilowatt is 1,000 joules per second. Then 1 kilowatt, if we multiply that by 1 hour, it means that it's going to become 1 kilowatt hour. If you to multiply times the hour, it's going to become 1,000 joules per second. Multiply that by the hours. In 1 hour there is 3,600 seconds, so it's going to be 3,600 seconds right there. When we cancel the second there and the second there, we remain with 3,600 times that, giving us 3.6 times 10 to the power 6 joules. So it means in 1 kilowatt hour, there are 3.6 times 10 to the power 6 joules of energy. So now this 1 kilowatt hour instead is the standard that is used by electricity utility companies in the billing of electricity. Liken it to this scenario, that instead of using this spoon to measure the sugar that I'm giving out as I'm selling, instead I'll use this cup. It is easier for me to scoop this cup, and I'll simply say that, okay, every cup that I am selling, I'm selling it at 1,000 shillings. So this cup is like the kilowatt hour, and this spoon is like the watt, the joule. So instead we're using this. So meaning that when we are billing electricity, we are simply going to use the kilowatt hour. So by definition, the kilowatt hour is the amount of energy that is supplied at a rate of 1,000 watts for 1 hour. And the number of joules of energy that are in 1 kilowatt hour are 3.6 times 10 to the power 6 joules, and this is how we're able to get those joules of energy. So in today's session, I get to explain how we calculate for the kilowatt hour in the billing of electricity coming up. An example, how much will it cost to run 2,000 watts electric fire running for 45 minutes if electricity costs 425 shillings per unit? Now we are aware that this unit they are talking about is actually 1 kilowatt hour. So it means that they're telling us that 1 kilowatt hour of electricity costs 425 shillings. So the question here is that we're supposed to compute how many kilowatt hours are in this electricity that is being consumed. Then when we are able to compute the kilowatt hours, then we are able to compare and see how much we are going to pay. So this one is running a 2,000 watt electric fire, and it's running for 45 minutes. So since it is 2,000 watts, it is running for 45 minutes. We're supposed to first convert this into kilowatt hours. When we convert it to kilowatt hours, then we are able to determine the cost. So it is running 2,000 watts. Those are 2,000 watts. So it means that 2,000 watts, to convert those to kilowatts, it means it's going to be 2,000 divided by, of course, 1,000 to make them 2 kilowatts. Now converted those kilowatts into hours. It means you're supposed to multiply this by the hours this thing was running. Now they're telling us that this 2,000 electric fire is running for 45 minutes. Now converting 45 minutes into hours will mean it is 45 minutes divided by that by 60 minutes. So it's going to become 2 kilowatts times the hours, which is 45 minutes divided by 60 minutes to convert this to hours. So it's going to become, by 15 is thrice, by 15 is 4 times. So it's times 3 over 4. This gives us by 2. So this becomes 1.5 kilowatt hours. So after computing it and converting it to kilowatt hours, now we can go ahead and know that 425 shillings is the cost of the unit, and the unit is a kilowatt hour. So we know that 1 kilowatt hour costs 425 shillings. So what about 1.5? So meaning 1.5 kilowatt hours will cost how many shillings? Put the unknown. When you cross multiply x times that, x is going to be this times that, which is 1.5 times 425, and therefore that will give us 637.5 shillings. In our other example here, we are being told that Umeme charges 425 shillings per kilowatt hour. Now, Umeme is an electricity utility company in Uganda. Umeme charges 425 shillings per kilowatt hour of electrical energy consumed. What is the total cost of operating 4 light bulbs rated at 100 watts each for 5 hours? So again, we need to first compute the kilowatt hours that are being consumed. Now, according to this question, they're telling us that there are 4 light bulbs. So there are 4 bulbs. Now each of these bulbs is rated at 100 watts, so it means that the total wattage that is being consumed by these bulbs is going to be 4 bulbs multiply that by 100. So together all these bulbs are consuming 400 watts. So now, but they are consuming them in 5 hours. So let's first convert these watts to kilowatts. Converting these to kilowatts, we divide that by 1000 and we are going to end up with 0.4 kilowatts. Now, so converting those kilowatts to kilowatt hours, it means you're supposed to multiply this by the hours it is running. So of course, multiplying that by the hours, it means this thing is running for 5 hours. So it means it's going to become 0.4. Multiply that by the 5 hours. And so 0.4 times 5 hours gives us 2.2 kilowatt hours. So it means that these 4 bulbs running at 100 watts each for 5 hours, they consume 2 kilowatt hours. So if they're telling us that every kilowatt hour is that much, we're able to get how much it's going to be. And in this case, we know that 1 kilowatt hour is going to cost 425 shillings. Therefore, 2 kilowatt hours is going to cost this times that, twice the other. So it means that is X giving us 2 times that, 425. And of course, in that case, our answers will be. So you can try out these numbers. Remember, the concept is very simple. You have to first compute how many kilowatt hours are being produced. Then you relate those kilowatt hours to the cost of each unit to be able to get how much. So that's the end of that question. You can let me know the answer you get in the description below. That right there is another question. You can still do it using the same concept. This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakuramia helping you manifest excellence.